Hello everyone, my name is Masheka Lewis and this is my Module 3, Chapter 10 presentation of length, area, and volume. Let's get started. Now, our first problem, we have A and B. Our first problem, they want us to create a photograph and show how many mouthfuls are in a gel of in a cup and in a pint. And then for our second part of the problem, they want us to create a photograph to show a mouthful, a jigger, a jack, a jill, a gallon, and pour it into an empty pail, which is what we got to show. So first, we need to create, let me move this, how many mouthfuls are in a jill. Let me move this over here, up here. Okay, there are 8 mouthfuls in a jill. Now we have to go into cup. There is 16 mouthfuls in a cup since a cup and a jill is times 2. And there is 32 mouthfuls in a pint. And that's because it is 3 times the mouthfuls of a jill. Now let's go to our next one. Our next one, they want us to do a photograph of a mouthful, a jigger, a jack, a jill, and a gallon, pint, everything into a pile. And see if it overflows or if it's going to be too little or just right. Now it'll be easy to make a chart like I did here so you'll know what it looks like. Now when you look at the chart, you'll see that everything is divided by 2, which means a pile is half, 1 gallon is half of a pile, 1 bottle is half of a gallon, and so forth. So everything's going to be half since they only want us to do 1 of each. Now we're going to have this basket that represents our piles that we are filling up. Now, like I said, 1 gallon is half of a pile, so this will be our pile. Our gallon. And then we have half a bottle, which is, a bottle is half a gallon. And then we have a quart, which is half of a bottle. Half of a quart is a pint. Half of a pint is a cup. Half of a cup, is a jill. Half of a jill is a jack. Half of a jack is a jigger, and half of a jigger is a mouthful. Now, that's all they want us to put in the basket, which means we have this little slit here, which means it is not overflowing, and we have room for one more mouthful to fit into the pile. Now, let's go to question 2. Question 2, they want us to find the perimeter and area of these objects, of these triangles. So to solve this, we must know what an area and perimeter is. So our area formula is 1/2 times base times height. Now we need to know what base times height to understand. So in this problem, we have 82.3 is our base and 41.0 is our height. Same for this one, we have 88.8 and 37.0. And for this one, it's a little weird because if this is not our height, but this is. So our height is 2.6 and our base is 6.2. Now that we know our base and height of each triangle, let's solve the problem. So for our first problem, we have 1/2 times 82.3 times 41, and we have 1,687. Hold on a minute. And now we have our second problem, which is 1/2 times 88.8 times 37.0. And this is our number we'll get, which is 1,642.8 inches squared. Make sure we have inches squared since we're doing area. And then we have 1/2 times 6.2 times 2.6, which is 8.6. Well, 0.6 centimeters squared. Now perimeter. Perimeter is different from area. For a perimeter, we're just going to add all the sides. So to solve the perimeter, let me move this real quick. We have a 48.0 plus 82.3 plus 69. And then we'll add all these sides as well. Now this, we do not use the height. We'll use actually 3.1 for this one. And this will be our perimeter. This is the perimeter for A, which is, again, 48 plus 69 plus 82.3 equals 199.3 meters. This is not meters squared because we are doing perimeters, so we're just going to add. And then we have 88.8 plus 37.0 plus 96.2. And then we have 222 inches. And then we have 3.1 plus 6.2 plus 8.5, 17.8 centimeters. Now, let's go to question 3. Question 3, they want us to find the area of the small circle, which is the one inside. And then they want us to find if the distance between the circles is the same. So to do this, you must find the area of the circle. Now to find the area of the circle, it is pi times radius squared. So we need to find the radius. How do we find the radius if they don't give us the radius? Now we have a circle, but we also have a square right outside the circle, and the circle is overlying with the square, which means the area for the diameter of the, for the square is the diameter for the circle. So we have a diameter of 10 for square, which means half of 10 would be 5. So our radius would be 5. Now we have our area, which is, again, pi times radius squared. We'll plug in 5 for our radius, and we'll get 25. Let's move this real quick. There we go. And now we have to find our area for our distance between the two circles. So to do this, we'll do the Pythagorean theorem, which is a squared plus b squared plus c squared. Now we'll draw a line for another diameter, which will give us our triangle that we need. And we'll have 5 squared plus 5 squared equals c squared. And that'll be our Pythagorean theorem, and that'll give us the number we need. So 5 squared plus 5 squared equals 50. And now we need to find the distance. So our distance will do 50 minus 25. And that'll give us 25 pi unit squared. So that means, in conclusion, the area of the small circle is the same as the area of the region between the circles. Now, problem 3. They want us to find the volume of all 3 objects in here, which is a cone, a sphere, and a cylinder. They also give us a radius equals r and a height equals 2r, which we're going to plug into our formula in a minute. So we need to find, they all have different volume formulas, so we'll have to find the volume of each of these. And then we have to find the ratio. Now to find the ratio, we're going to divide all of the volumes that we find, and then divide it by our cone volume. So first, let's start with our cone. I'm going to have to move this again, sorry. Now, our volume of a cone is C equals 1/3 times BH. And our base, which is B, and our height is H. So area base is pi times r squared. Our base is r, like they gave us. And our height is 2r, which they gave us. So we'll plug this into 1/3 BH, which will give us equals 2/3 pi r squared. Pi r cubed. I'm sorry, because we're finding volume. Now we'll do the same thing for our cylinder. Our cylinder volume is B times H, which is base times height, which our height is 2r and our base is r, and that will equal our volume is 2 pi r squared. Base area, which is pi r squared. I'm sorry, wrong one. I said base on the base area. And then we have our volume over squared, which is 4/3 pi r squared. And that's because we don't have any base or height. So we'll just use this as our volume. Now we'll divide each by the cone. So when we divide each by cone, we get a 1. When we divide 4/3 by 2/3 pi r squared, we get 2. And that's our sphere, which we got down here. And now the volume of the cylinder, which is 2 pi r squared, divided by 2.2/3 pi r squared, which will give us 3. and our ratio is 1 to 2 to 3. Now, question 5. Oh, that went by fast. Okay, let's move this. Now, we have to name two figures and find the surface area of both figures. Now, surface area, we have to find a volume. And surface area, we have a formula to find surface area of the of the figures. I'm sorry, you can tongue tied. And these are two figures that we're finding. We also have to name the figures. Now, our figures, we're moving again, is a trapezoid prism. Now, they give us a surface area formula, which is 2b plus ph, and these are the case for both of our surface objects. So we need b, which is base. So our base in our trapezoid prism is 26 and 17. And that's because we're doing the trapezoid and not the, we're not focusing on anything else but the trapezoid. The 15 right here would be actually this line right here. 17, because it's the same, is equal to this one, this line as well, because they're parallel. So we have our b, which is 1/2 times a plus b. A would be 26, b would be 17. We have a p, which is perimeter, and then we have h, which is our height. And this is where the 4 will come in. So let's find the base first, which again, 1/2 times 26 plus 17 times 12, which is 258. We have a perimeter, which is adding all the sides. Now we do not include the 4 because we're only finding the sides of the trapezoid right here, which is 26, 12, 17, and 15. And that'll give us 70. And then we have a height, which is 4. That is where the 4 will come in. And now we'll just use the formula 2b plus ph. We'll plug in our figures that we just found, and then we'll get 796 centimeters. Now we have a right triangle prism. Now we're focusing on the triangle this time and not the square. So to find the surface area, again, it is 2b plus ph. Again, b is base, p is perimeter, height is h. Now we have bh. Now we don't have a plus b because we don't have a trapezoid. We just have b, which is our base. Now to find the base, 1/2 times 15, which is our base for the triangle, and height, which is 8, which is our height for the triangle, which will equal 60 meters squared. Now in perimeter, we'll add all the sides for the triangle, which is 8, 8, 17, and 15. And that gives us 40. And our height is 7, which is right here. Now we'll just plug in the formula, which is 2b plus ph. Find the numbers that we put in, and that'll give us 400 meters squared. Now, our last question. We have to find the surface area and volume of these two solids. Now, we have to add, okay, now we just found the surface area, but this problem we have two, I'm sorry, I need to put, let's see if I can have a pointer. Maybe that'll be easy to keep track. Now we have two areas, which is, two objects, which are a sphere, and then a cylinder, and then we have a cone and a cylinder. So to find the surface area, we're going to have to find the surface of both objects individually and then add them together. Same that goes with this one, this object, which is a cone and a cylinder. And to find the volume, we will just plug it into a volume formula, which I'll show you. Now, again, surface area and volume, cylinder, and our sphere. Now we have our surface volume first. We're going to find our surface area, which is sphere. Our surface for sphere is 4 pi r squared. Cylinder is 2 pi r squared. And like I said, we're going to add them together. So we're going to plug it in. Now we need to find a radius to this first. Our radius is 4 because 4 is half of 8, and 8 is our diameter. Radius is half the diameter. So we'll plug in both of our formulas, and then we'll find out that it equals 232 pi feet squared. Now we'll find our volume. which is for the whole entire object, which is 4/3 pi r squared, pi r cubed, since we're volume, plus pi r squared h. Now we just have to plug in our formulas, which is 4/3 pi radius, which is 4, cube times pi 4 radius, cube times height, which is 21. And oops, sorry. That'll give us our our answer of 421.3 pi, or 422 if you round it. Now, you cannot include pi and instead use 3.14 like I'm about to do for the next problem, so you'll know how to do it both ways. Now we have a cone and a cylinder. Like the surface area for the last problem, we'll do the same for this problem, which is find the volume separate, find the surface area separate and then add them together. So when we do this, we'll put in our radius, which is 2, radius 2 times pi times 6 plus, or 6 is our selected height, and depth with, S is selected height, and selected height is our 6. I should have said that before, I'm sorry. And then we have 2 radius, it was pi, 2, and 10, which is our height. We'll add that together, and this time we're going to plug in 3.14 for all of our pi's, and we'll get 175.84 or 176 if you round. Now we have volume, which is again pi r squared h1 plus 1/3 pi r squared h2. Now you might try and say, like, what is h1, h2? We already know what h is, which is height, but we only seem to have one height. But the thing is, we actually have two. We have the height for our cylinder, which is 10, which is going to be h1, and we have a height for our cone, which is h2. But right now, we don't have a height. We only have the scientific height and the radius. But you can use the Pythagorean theorem, like we did earlier on question 3, and find the height of the cone, which is c squared minus 2 squared. Our Pythagorean theorem is a plus b plus c squared equals c squared. But since we don't have b squared or a squared, we're going to have to do it the opposite way, which is c squared minus a or b squared, and that'll give us our missing side. So we have a c squared minus 2 squared, which is our radius, and that'll give us our height, h2, which is equals to 5.66. Now we'll just plug in our values for our objects, which is pi, which we're going to put in 3.14 times 2 squared times 10 plus 1/3 times 1.3 squared times 2 squared times 6.66. And again, we did 3.14, so we're not going to bring down the pi like we did in the last problem. And we're going to have 149.3 or 150 meters cubed because it is volume. And that's it. That's the presentation. Yeah. I hope you all have a nice day and learn something. Have a nice day.